Good morning, grade 10. Before we start our lesson, kindly bow your head, close your eyes, and let us pray. Mahal naming Diyos, maraming salamat po Panginoon sa oras na to. Lord, dinudulog po namin sa inyo lahat ng aming gagawin, O God. Tulungan mo, O Lord, ang mga grade 10 na maintindihan po nila ang aming mga lesson sa araw na to. Maraming salamat din, O God, sa patuloy na proteksyon mo sa bawat isa, bawat pamilya po namin. Nagkakaisa po kami, O God, nananalangin, Lord, na matapos na po, O God, ang pandemic na to, na dala ng COVID-19. Maraming salamat po sa lahat, O God. In Jesus' name we pray. Amen. Chapter 2, A Deeper Look at Polynomial Functions. Section 2.1, Polynomial Functions and Their Graphs. Kindly open your book and read pages 56 to 68. Math may not teach us how to add love or subtract hate, but it gives us hope that every problem has a solution. Our lesson for this morning are describe what is polynomial functions and their graphs, zeros of a polynomial functions, symmetry, power functions, properties of power functions, and increasing and decreasing functions. A polynomial function is a function such as quadratic, a cubic, a quartic, and so on, involving only non-negative integer powers of x. We can give a general definition of a polynomial and define its degree. The most common types are zero polynomial function, linear polynomial function, quadratic polynomial function, cubic polynomial functions, and the last one, quartic polynomial functions. We can classify or identify polynomial using the degree and the number of terms. Example number 1 is 5. That is a constant. Degree 0. Number of terms 1. So we call that as monomial. Another one is x plus 4. What is that? That is a linear. Why? Because composed of two terms. Then the degree 1. How can we identify the degree? The exponent. So there is no exponent, so automatic, that is 1. How many terms? 2. X plus 4. Then, what is the name of that polynomial? That is binomial. Another example, 4x squared. What is the degree? 2. Because the exponent is 2. How about the number of terms? That is only 1. So we call it as monomial. But the degree, we call it quadratic. Why? Because the exponent is 2. Another example is 2x4 plus 5x squared. So what is the degree? 4. The highest exponent is 4. The number of terms, that is only 2. Then we call that as binomial. But the degree is 4, so we call it quartic because that is 4. Another example, negative x5 plus 4x squared plus 2x plus 1. What is the degree? 5. The highest exponent is 5. We call that as quintic. Then how many degree? 4. So we call that as polynomial of 4 terms. This time we are going to study the parts of polynomial. First, the leading coefficient. A coefficient of a variable that have a highest degree or polynomial degree. Then, polynomial degree, that is the highest exponent. Then the last one is the constant term, a number without any variable. Zeros of a polynomial function. A polynomial function is usually written in a function notation or in terms of x and y. Like for example, the function of x is equal to x squared plus 2x minus 15, or y is equal to x squared plus 2x minus 15. The zeros of a polynomial function are the solutions to the equation you get when you set the polynomial equal to 0. Zero product property for all real numbers a and b. If a multiplied by b is equal to 0, then a is equal to 0 or b is equal to 0. Example, 0 is equal to x squared plus x minus 6. So what we're going to do first? Find the factor. So what is the factor? X plus 3 and x minus 2. X plus 3, that is your A, and x minus 2, that is your B. Then, by the zero product rule, we are going to find the value of x. So what is your x? X is equal to negative 3, then x is equal to 2. Check your answer. Just substitute the value of x. For the first is negative 3. Just substitute it. So, your answer is correct. The same with x is equal to 2. Your answer is also correct. Example, how to find zeros of a polynomial function. So the first thing that we're going to do is factor the given equation. Then after factor that one, you're going to find the value of x. Then, if you want to check your answer if it's correct, just substitute the value of x to the original equation. These are the illustrations of the different kinds of functions based on the degree. What is symmetry? The quality of being made up of exactly similar parts facing each other or around an axis. And a line of symmetry is a line that divides a figure into two equal or congruent halves. Symmetry and math. Symmetry is present in even functions. They are symmetrical along the y-axis. Symmetry is present in odd functions as well. They are symmetrical with respect to the origin. They have order to rotational symmetry. What is a power function? A function with the form y is equal to axb, where a is a real number and b is a rational number. When b is a positive integer, a power function is a type of polynomial. For example, y is equal to axb is a linear where b is equal to 1, quadratic when b is equal to 2, then cubic when b is equal to 3. These are examples of graphs depend on the number of degree. Like for example, y is equal to x. Number 2, x squared. Number 3, x cubed. Number 4, x to the fourth power. And the last one, x to the fifth power. The end behavior of a polynomial function is the behavior of the graph of the function of x. As x approaches positive infinity or negative infinity. So the sign of the leading coefficient is sufficient to predict the end behavior of the function. The end behavior of a function describes the behavior of the graph of the functions at the ends of the x-axis. In other words, the end behavior of a function describes the trend of the graph if we look to the right end of the x-axis as x approaches positive infinity and to the left end of x-axis as x approaches negative infinity. This is an illustration how to find the end behavior of a function. So based from the table, you can identify the graph based from the leading coefficient and also what kind of behavior. Like for example, the given is y is equal to x squared. What is the sign of the leading coefficient that is positive? If that is positive, rise to right, then that is positive infinity. Then the same way, rise left, automatic, that is negative infinity, but the leading coefficient, that is a positive. So automatic, your end behavior is positive. Opposite with the negative leading coefficient. So you know already how to find the end behavior of a function. If the functions f and g are increasing, decreasing on the interval a, b, then the sum of the function f plus g is also increasing, decreasing on this interval. If the function f is increasing, decreasing on the interval a, b, then the opposite function become negative, is decreasing, increasing on this interval. To find the unincreasing or decreasing interval, we need to find out if the first derivative is positive or negative on the given interval. So find by decreasing its exponent by 1 and multiplying by the original number. Next, we can find and see if they are positive or negative. Increasing and decreasing function. Number 1, if x or function of x is greater than 0 for every x on the sum interval 1, then the function of x is increasing on the interval. Number 2, if function of x is less than 0 for every x on the sum interval 1, then the function of x is decreasing on the interval. Then, number 3, if or function of x is equal to 0 for every x on the sum interval 1, then the function of x is constant on the interval. Ibig sabihin, pag ang x po natin ay mas malaki kaysa 0, so automatic, that is positive. So, your function is increasing. But, if your function of x is less than 0, pag less than 0, automatic, ayan po ay negative number. So that is decreasing. Then how about pag x mo ay equal to 0, ibig sabihin yan, constant po. That's how to identify if your function is increasing or decreasing. Grade 10, your assignment, advanced reading, division of polynomial, the factor theorem, and the remainder theorem. Pages 69 to 76. Thanks for listening. God bless. Grade 10.